Hello, dear students. Greetings of the day. I, Mohammad Zishan, welcome you to the online classes of Blooming Birds Code School, Sambal. Dear students, this is the sixth lecture of chapter number 3, Rotation and Revolution, and it would be the last lecture of for this chapter. In this lecture, we are going to study about the twilight in low and high latitudes. Now, what is the meaning of twilight? Twilight is the time when we receive the diffused sunlight. When you wake up early in the morning at 5 o'clock, and the time which when the night is passed on and the day is breaked out, that time till the time of sunrise, when sun appears to be rising in the east, that time is called twilight or dawn. And in the evening, the time which starts after the setting of sun till the complete darkness, that much diffused light, or the duration of that diffused light, the duration which is between the setting of the sun in the west and till complete darkness, that time is also called twilight. So the morning time, morning twilight has been given a name dawn, right? And the evening twilight has been given the name dusk, right? So why this phenomenon takes place when sun is not visible to us from where the light comes? So that is the scattered light. So it is like this. Suppose if you are here, this is the earth, right? And this is your horizon. If the sun is below 18 degree, if the sun is here below the horizon, right, then you'll not be able to see the sun will not appear to you, but still the sun is scattering its light everywhere, right, like this. Now the clouds which are in the atmosphere, the dust particles all over, right? So these get lights, and this light is reflected or refracted, okay, scattered, and we receive here very dim and diffused light, diffused and dim light. That diffused and dim light is called what? Twilight, right? In morning time it is called dawn, and in evening time, evening twilight is called dusk. So then afterwards, what happened? Afterwards, when the earth keep rotating, so this condition one is how on the earth it is like this. Suppose we are living here in India, clear, and India is here, right, and the sun is here, clear. Now this will be the horizon. Just a moment, please. This will be the horizon for India right now. Okay, like this, it will be the horizon. Huh? So, if this is horizon and sun is here, so obviously we cannot see the sun is below horizon. Okay, when earth keep moving like this, keep moving like this, keep moving like this, and when the angle, this angle becomes 18-degree, right, then what happen, then the sunlight will fall all over, okay, here and in the atmosphere, right. So the atmosphere which is here, okay, which is upside India, that will also receive the sunlight. So the dust particles and the clouds, okay, they will reflect back the light, okay, and like this India will start receiving very dim and diffuse light in that manner, okay, and that time will be called what, the dawn time, right, in the morning, and the dusk time at the evening. Just both phenomena are called as twilight, okay. Now when the earth's horizon, okay, when will be like this, and uh, it comes to the sun, then what will happen, sun will start appearing in the east, okay, and that will be called sunrise. And when the India will be directly in front of the sun, right, the sun rays will fall perpendicularly, right, or the sun will be at the highest position in the sky from India, right, then that time will be called what, the noon in India. Clear? So earth will keep rotating and the evening will come, right. So like this these phenomena takes place. So here what will happen then, this is again, this is horizon and you are standing here, then sun will reach here above the horizon, okay, and this will call sunrise, right. And when the sun will keep moving and will reach here, this position will be known as noon, right. Clear? When it is having this, sun is overhead or the shadow of the sun is shortest, then it will again go below the horizon, right, and that will be sunset. Clear? And till 18-degree, right, when it reaches here till here, you may experience what, this period as twilight or dusk, when sun comes from here to here, right. So these are the phenomena of twilight, dawn, dusk. I hope you would have understood that. Now as we know that uh, at equator the sun remains vertical most of the time, okay, and at tropic of Cancer also and tropic of Capricorn also sun rays falls uh, at 90-degree angle on 21st June and 22nd December respectively, right. So this area, on this area sun rays falls directly on at some time, okay, and particularly at equator. So at equator the duration of sunrise will be sorry, the duration of twilight will be very less, okay, maybe 1 hour, right. And as we keep, why it will be 1 hour, suppose this is equator, clear, if some country is here like this here, and sun remains most of the time like this in front of equator. So when it is in front of equator, then what will happen, within a period of there at this place in Africa, right, they will be dark if it is like this, clear, there will be darkness, night will be there, and when it will keep rotating, keep rotating, keep rotating, and it will come like this, right, when the angle of sun will be 18-degree, okay, then what will happen, it will start receiving diffuse and dim light. But as the earth is moving very fast, okay, the speed of rotation is very fast here, then what will happen, it will move very fast and it will come in front of sun quickly, right, in front of sun quickly, right. And because of that what will happen, because of that it will receive very less the twilight will be for very less duration. Whereas the places those are on the higher latitudes, their speed of rotation is slow, right? So they rotate slowly, and they are on the curved side of earth, right, upside, where the sun rays fall slantingly, making an angle of 40 degree, okay, or 30 degree, or 23 degree, right, and even sometime 0 degree angle, right? So when the angle, so the sun rays are falling at lower angle, okay, then at those places where the sun rays fall slantingly, right, those places will experience twilight for more hours. Why? First reason, because sun rays are falling slantingly there, okay, the angle of incidence is low, very low, right? And the second thing is that, okay, these places, the speed of rotation at the higher latitudes is very slow. Speed of rotation at higher latitude is very slow. So these are the two reasons why the twilight duration is longer at as we move towards poles, okay, at the higher latitudes. I hope you would have understood all these things. So that was all in twilight in low latitudes and high latitudes. In low latitudes like equator or 10 degree, 20 degree, 30 degree, the twilight is for very less duration, maybe 1 hour, 20 minutes, like that, okay. And as we move towards the pole, the duration of twilight becomes more, and these areas, especially the region near the Arctic Circle, these areas receive most of the time diffuse light. Diffuse light, why? Because their position is such that okay, angle of incidence remains very low, okay. Angle of incidence of sunrise remain very low in this manner. Like, I'll show you two things here, one at equator and another at poles or higher latitudes. Suppose you are here, so you will observe sun rising this way, going overhead like this vertically, and coming this way, right, at the, this will be 90 degree, clear? And this is at equator or at tropic of Capricorn and tropic of Cancer. And places which are at higher latitudes, which are at 50 degree, 45 degree, okay, or 60 degree or 90 degree, okay, their angle of incidence is very low. Sun rises this way here, this much time remain for twilight, okay, at these places, and then goes till here and then sets here. Means the sun will not be overhead like here at equator. You will find during the month of June here in summer, you will find that sun rises in the east and then go upside like this, okay, and then sets this way, right, this way, clear? But during winters, the sun rises this way and then just rises till here and then sets like this, okay. It doesn't go over the head, okay, it remains at a lower angles in the sky, clear? So that is the reason Here it sets, sunrise you can say here, sunset you can say here, and this region, this position, this much will be what? Twilight. So this is how the sun rises and ascend the highest position in the sky and then sets. Okay, so this was about twilight. The chapter is completed. I hope you would have understood all these things. For more clarification, you should read the book and like, subscribe, and comment.